Hi, you're watching Omaha Chemistry Tutors video tutorials at getsupersmart.com. I'm Cecil Brazier. Today we're going to be talking about significant figures, and I'm not talking about these kind. All right, significant figures are basically a way of um, giving someone confidence in a measurement. Okay, sometimes we call them sig figs. All right, the easiest way to talk about these, I think, is to break them down into groups. So first we're going to talk about numbers that are greater than or equal to 1, and then we're going to go back and talk about numbers that are less than 1. All right, so this tutorial is all about how to count significant figures in a given number. All right, so let's start with numbers greater than or equal to 1. So here we have 1 million, okay? No decimal. All right, and that's important. If you don't see a decimal here, then the first thing we have to do is count to the left. All right, so we start where the decimal would be, and we're going to start looking at each digit to the left until we've come to the first non-zero digit. Okay, so all these are zeros, so I'm going to pass them up, pass them up, pass them up. Okay, now we have a non-zero digit. It's the number 1. Okay, so our first non-zero digit and everything further to the left is going to be significant. Okay, well, in this case, we only have one number. All right, so 1 is our first non-zero digit here, and it's also the only significant figure. All right, so one significant figure here. All right, so let's go to 1,000. Okay, again, first thing we look for is a decimal point, and we don't have one. Okay, so we're going to start where the decimal point would be, and we're going to move to the left until we find our first non-zero. Again, here we find a 1. Okay, so this is our first significant digit. Everything to the left, if there was anything, would also be significant. Okay, but in this case, all we have is the 1. So again, one significant figure. All right, next example. Again, no decimal point. So we're going to move to the left until we find our first non-zero. And here we go, 1 here. All right, so that's our first non-significant or significant figure. And everything to the left of that is also going to be significant. Okay, and you'll notice that there is actually a 0 in here. So it's not that zeros can't be significant. It's just that they have to be in a certain place before we can count them as significant. Okay, and without that decimal point, they can only be significant when they're in between two other non-zeros. All right, so we found our first non-zero as 1. Everything to the left is also significant. So 1, 2, 3 significant figures here. Okay. All right, again, no decimal point, so we're going to count to the left until we find our first non-zero. Well, we found it right away. All right, so that means that everything to the left here, including that first non-zero, is going to be significant. So in this case, all of our digits here are significant. So 1, 2, 3, 4, 5, 6. 6. Okay, not so bad, right? Basically, all you need to do is if you recognize that there's no decimal, all right, we don't count significant figures until we get to the very first non-zero. Okay, so in that case, it was there. In this case, it was here. In this case, it was this 1, okay, but we also include everything to the left. Okay, so that's where we started our significant figures, and we kept going until we came to the end. So we had 3 there. Here we had a non-zero right away, so we were able to count everything. All right, so that's how that works. All right, so what if there is a decimal? Well, the decimal is sort of a flag. It's sort of like a, hey, everything to the left of me and even to the right of me, if I'm a greater than or equal to 1, okay? Remember, all these numbers we're talking about so far are greater than or equal to 1, so keep that in mind. All right, so this decimal here is saying, okay, now I'm confident that all the numbers to the left are significant. All right, so that's nice. Now we're not having to skip these zeros, okay? Because that decimal is there, all right, it's telling us, hey, everything to the left is significant. All right, so now up here with this 1 million, I can only count this one, right? Because there was no decimal. Here I get to count all of them. So 1, 2, 3, 4, 5, 6, 7 significant digits or significant figures. All right, same thing with 10. Before, without the decimal, we would only have 1, right? Because we wouldn't count that 0. But because that decimal exists, it's saying, okay, everything to the left is significant now. All right, so 1, 2 significant figures. And again, all right, now this is a different situation, right? But remember, since we're still greater than or equal to 1, right, that means That decimal means that everything to the left and to the right, okay, so if we have something to the right of the decimal here, even if it's a 0, that's all significant, all right? And it's because we're greater than or equal to 1. We're going to talk about numbers less than 1, and they have some special rules. But as long as we're greater than 1, that decimal means essentially everything in that number is significant. So 1, 2. Okay? Again, we're greater than 1, and we have a decimal point. So it's basically telling us everything in this number is significant. 1, 2, 3, 4, 5, 6, 7 significant figures again, okay, because I got to count them all. All right, so that's basically significant figures for numbers greater than or equal to 1, okay? Pay attention to that decimal. That's going to tell you whether or not you count these zeros here or you don't, okay? So if you don't have that decimal, remember, you've got to go to the left until you find the first non-zero digit, okay? Then you start counting. If you have a decimal, things get easy, all right? You can basically count everything. All right. All right. So what about numbers less than 1? All right. Well, they have somewhat similar rules to these numbers over here that didn't have a decimal, where we had to wait until we found the first significant digit. All right. But the difference is, with a number less than 1, okay, we're going to start counting to the right. All right. So in this case, we're looking for the first non-zero digit to the right of the decimal. All right, so all of these zeros, again, aren't going to count. Here's our first non-zero digit, and it's a 1, okay? So we only have one significant figure, all right? This works almost exactly the same way as it did over here, except that now we're counting to the right of the decimal, all right? And the only reason we're doing this is because we're less than 1, okay? So keep that in mind. All right, so again, we're less than 1 here, right? So we're going to count to the right of the decimal until we get to our first non-zero. Okay, so 0, 0, 0, 0, 1. All right, there we go. Again, once we find our first non-zero, everything to the right is going to be significant, even though this is a 0. Okay, once we hit our first non-zero, everything to the right is going to be significant. So in this case, 1, 2 significant figures. All right. All right. So next example. All right, I didn't put the first 0 in here, but obviously this is implied to be less than 1, right? So we start here at our decimal, go to the right. First non-zero is right here, so 1 significant figure. All right, one last example. All right, 0. All right, here's our first non-zero. Everything to the right is significant, so 1, 2, 3. 3. All right, and just because I want to point this out, I'm going to make one more example here. I'm going to make it 0.001, 1, 2, 3, 4 zeros, okay? Because I want you to realize that in this case, when you're less than 0, or I'm sorry, less than 1, once you get to that first non-zero, okay, here it is, everything to the right, no matter what it is significant, okay? So 1, 2, 3, 4, 5 significant digits. I just wanted to point that out so there's no confusion, as once you get to that first significant digit, even though the rest of these are zeros, I mean, they could be anything, okay? But no matter what they are, they're significant, all right? So 5 significant digits here. All right, so it's obvious that there's an issue with how we have to count these things up in this form, okay? When we have to look at numbers like this and we have to say, okay, where's the decimal point? Is it greater than 0? Is it less than 0? Okay, so we want to find a way that, an easier way and a more consistent way to represent these numbers so that we always know how many significant digits we're dealing with. It's not ambiguous. We don't have to make decisions. We just know, okay? And that method is what we call scientific notation.